In this next problem, a chemist mixes 2 parts acid to 3 parts water. And they're asking how much acid would the chemist mix with 300 milliliters of water. So we are having a ratio of acid to water. So I'm going to say 2 parts acid to 3 parts water. I don't really have a units there, but I need some form of label. That will help me to set up this proportion. How much acid? Well, that's going to be X acid is going along with 360 milliliters of water. Notice how the units acid, and water are lined up. Now I really don't need those units anymore, and I can do some cross multiplication. Or I can notice a shortcut if I know how many times 3 goes into 360. If you don't catch that, let's do our cross multiplication. One diagonal is going to be 3x. The other diagonal is going to be 2 times 360, which is 720, and there was a unit there of milliliters. So we have 3x is equal to 720 milliliters, and I want to divide each side by 3. That will then give us x is equal to 240 milliliters of the acid which needs to be mixed. Now, similar figures are figures that are the same shape but not necessarily the same size. They're enlargements or shrunk down versions of each other. Now, what you want to do is find the corresponding sides that match up with each other. Here we have that the 9 meters matches up with the 3 meters. So you could pretty much just say, in this case, that the figure on the left, not drawn to scale, is 3 times bigger. So I could take my 4, multiply by 3, and find out that x would be 12. And if I've got the 15 here, and I need to find y, I can divide by 3 to get y, and find out that y would be 5 meters. But that's only because the numbers are nice and clean. If these are lined up such that the corresponding sides are right aligned with each other, you can do the following. You can say, I'm going to create a proportion out of the left side of the base from each of these. I can set up the proportion 9 over the x, that's the left side over the base, from the first figure, is equal to 3 over 4, the left side over the base, from the second figure. Likewise, if I need the y involved, I can probably set a proportion this way. 9 and 15 corresponds with 3 and y. 9 is to 15 as 3 is to y. Now I have 2 proportions that I can solve to find the values of x and y. In this first one, I'm going to cross multiply. The diagonal with the x in it has a product of 3x. And the other diagonal, 9 times 4, is 36. And if we divide each side of that equation by 3, the 3's cancel and we get x is equal to 12 meters. And that's our value of x. Likewise, over here, I would reduce this first fraction first. 9 and 15 are both divisible by 3, and I can turn that into 3/5 and say, my y is just going to equal 5, because if the numerators match, the denominators should match with each other. In this last word problem, it says an 18-foot flagpole casts a 4-foot shadow. How long would the shadow be for a 90-foot building? Well, you also need to know that it's going to be done at the same time of day so that the angle of the sun will be the same in each triangle we draw. I'm going to draw a quick picture. Here's my flagpole, and it's casting a shadow. The flagpole is 18 feet tall, and it's casting a 4-foot shadow. This is not being drawn to scale. And then we've got this big, huge building here, 90 feet tall, and we want to know how long will its shadow be down there at the base. Okay, really not drawn to scale, really crude drawing. You're probably laughing at home right now. Let's see what we've got. I can match up the corresponding sides. I can say 18 over 4 is equal to 90 over x. And before I cross multiply, I'm going to reduce. 18 and 4 are both even. They can both be divided by 2, and that gives me 9 over 2 is equal to 90 over x. And I can now just see, without cross multiplying, that the second fraction is 10 times bigger. or well, the numerator is 10 times larger and the denominator is 10 times larger. So 2 times 10 is going to be 20, and x is going to be 20, and we will have a 20-foot shadow.